to Pinnacle BIM Series. We deeply appreciate you for joining us today's webinar titled From Blueprint to Build, Optimizing Concrete Construction with BIM-Enabled Quality Control and Quality Assurance. We are really glad that we have an audience from around the globe, and the response has been, you won't believe, is amazing. Thank you very much for that. I am Dipanjan Bakchi, working in Pinnacle Infotech Solutions in the 7 years, and I am currently working as a project delivery head on US concrete segment. And I'll be the moderator for today's webinar. And alongside with me, I have a leading BIM leads in our organization, Mr. Pritam Boral, Vabika Borawat, and Bhaumik Upadhyay. Now I would like to ask three of you, please introduce yourself to our audience.
Hi everyone, I'm Bhavika and I'm currently working as a client relations manager here at Pinnacle. Previously, I've worked as a project manager and a VDC coordinator for BIM inspection and BP development for Middle East. And I'm looking forward for a really insightful session today.
Hi, this is Bhaumik Upadhyay. I am licensed professional engineer with 6 years of experience in structural engineering and forensic engineering. I have been with Pinnacle Infotech for 3 years, working as a account relationship manager, and I'm based out of Houston, Texas.
Hi, this is Pritam Boral. I am here for last 10 years. I am working as a project delivery head for a US concrete team. I am leading a team of 30 people and having the projects of US concrete.
Thank you all for the brief introduction. So let's get started. So in today's webinar, we will discuss about how BIM-enabled quality control and quality assurance helps the concrete constructor in the field. So please keep sending your question in the question box throughout the section. We would really like this webinar to be more interactive. So let's get started, everyone. Now, let's have a quick key points what we'll be discussing today. Number one, empowering quality control in construction with BIM-enabled technology, transforming construction visualization with BIM technology, smart building, smarter maintenance, leveraging BIM for improved operations. And number four, building better with BIM-enabled automations. And number five, collaborating for success, leveraging BIM in technology in concrete construction. Now, let's start. Why BIM enable quality control important for project manager? That is a very crucial questions, and there are three subcategories that we'll be discussing today in detail in our upcoming slides. So let's have a brief idea about these three key points. Number one, first key point would be feasibility assessment, on which we'll be addressing pre-construction issues and how this will help in identifying error before the actual construction even starts. The second key point that we would be discussing, that would be improving construction quality with the BIM material and equipment tracking, on which we'll be highlighting how BIM models and process helps in improving the construction. And the last one would be the real-time tracking and monitoring of construction progress, through which we'll be able to track construction progress and status of the structure. Now, BIM or Building Information Model brings a collaborative approach, to construct, improve project quality, delivery, and reduce cost by mitigating potential constructability error in the pre-construction stage itself. As you can see in this slide, potentials constructability issues could be identified through BIM models. Let me go through the slides a bit. The first snap on the top that you can see on the top left-hand corner, that is the BIM model that we have found when we are working as a coordination project. So you can see after placing the BIM and placing the window opening, they're literally clashing with each other. So we address this to our client, and a client immediately they have just started working on that and changed the design by removing the BIM, just adjusting the BIM depth and having an upstand over the landing. So how this will help, to eliminate these kind of coordination issues. The second on the top of right, you can see the BIM that is running parallel along the stair is basically clashing with each other with the stair. So that is how, that's very crucial stage when we identified that, and we just raise this issue to the client. Client immediately start working on that. After a few days, we suggest something that we can reduce the depth, or we can suggest something from our end. So they took our suggestion, they revised the BIM depth, and now we can see in the right hand side there is no clash. Now it is completely a clear coordination. Now the third one, that is the bottom of the window that you can see, that after placing the window opening and the raised slab, that is one kind of, the secondary slab is there. So by putting these two together, what is happening, the slab is completely clashing with or obstructing the window opening. So that's not going to be an ideal thing in the construction. So we showcase this to our client and suggested something that if we can shift the opening and put a boundary on the raised slab by which design errors can be minimized, or also the construction or coordination issues can be also be identified. So client took our suggestion. So they put something like this. After that, you can see the sample cutout now been modified. These have been shifted, slab has been adjusted, and the parapet wall has been placed on that. So by how this helps in means rectifying the designs and the potential issues early stages, they can define through the BIM. And the last one you can see, this is one of the running project that we have faced. So you can see at for the structural section on the sumpit area, the slab is completely intersected with the core wall. That's not going to build, guys. So you all know that we need a sumpit on the core elevator core area. So this we are generally means asked to our client that if this isn't going to be found, what we should do. So client said just put whatever you wanted to have, whatever you think going to be have. So we put some suggestion over here, and client they have seen that and they have took it. So you can see now after correction, there is the slab is going to be eliminated at the edge of the wall, and there is some pit is also there. So how this help, how we are helping the client or we are helping the audience to identify the error, to identify the design issues before the actual construction even begins starts. Now I would like to ask Pritam, as Pritam is also a project delivery head in US Concrete Sen. Are you do you think this is going means are you feeling the same thing, or you are offering something different to the client?
Yes, Dipanjan, I am facing these same kind of things. Actually, not really actually these things. I am facing some different things. But one key area where my team uses BIM for quality control is feasibility assessment, which helps in identifying and rectifying the design and construction issues. Just very similar to what you have explained actually.
Right, right. That's why we are doing at Pinnacle.
Mhm.
So, okay, just for the audience, I'm going to take a much more in detail, examples that I have from my live projects that we are working in Pinnacle. So this is one of the coolest example that you can see here. So basically what is happening, there's a pile cap over here. Let me just go to the scenario at once. There is a pile cap here. And after coordinating the MEP model to the structure one, we can clearly see the conduits are clashing with the pile cap. And that is not going to build like that in the construction. We all know about it. So we just really took a snapshot we using Revit and Navisworks also. We just took a snapshot over there, put it to the client, and they responded back through an RFI or design changes. They said like, yeah, you need to step down the file cap by 1.6, by which there will be no clashes involved with the MEP thread. Another one, this is one of my favorite because this is sometimes some related to designing aspects as well. So you can see the turn down wall between the slope poured after pouring the slab on grade, but as per the difficulties of formwork and rebar arrangement, the pouring of the turn down needs to be changed. So Pinnacle addressed this to our client. Client instructed that the turn down wall will be grouped into the slab on grade, and then the outer side of the slab will be poured together, just like a monolithic structure. It is not going to be a turn down wall separately, because the rebar arrangement will be go with the same. So what they decided on the field, they're gonna cast it together: slab on grade, turn down wall, and the thickened edge. The three things will be casted together like a monolithic structure they're going to add. Now, this is my one of my favorite. So we can see the two thickness of the shear wall is basically intersecting with each other, but there is no overlapping zone. So we thought this is one of our scope that we need to build the rebar arrangement as well. So you can see there is no transition where the slapping will be there. No cover, or some design specifications are following at that time. So ask this to client how we're going to build that. So what client said, just put an extra concrete where it is going to be transited. So what will happen, the proper cover will be there. So that is how we are helping our clients to get this thing sorted before the actual construction even begins, and not the actual construction, at the very initial stage when the drawings are means on the bid stage or permit stage. So we address this to our client at that time.
Right. And Dipanjan, in one of my projects also, I had a similar kind of issues. We were working with beams. So there were two adjacent beams with different sizes, and we had to
Okay.
provide a corbel, a single structural corbel to them. So in that
Okay.
area, we had to provide one concrete pad, uh, thickened area to, help with transitioning of the beam. So these
Right,
kind of
right, right.
issues are
Yeah.
really common. Yeah.
Yes, yes, absolutely. That is the beauty of the BIM in our
Yeah.
industry, because our industry is working on it, and the concrete contractors who on the field, they do not much are aware of the designs or what is happening. So through BIM models, we can clearly rectify it, and means we can showcase this to our clients, so they will be also happy to see this.
Right.
Yeah. Now, another aspect where BIM can use or BIM can help in improving construction quality with BIM material and equipment tracking. With the BIM, the information about the material and equipment can be added to a digital model, so making it easy to track, manage them throughout the construction process. This helps to ensure that the right material and the equipment are used at the right time, which helps to improve the quality of the construction. In addition to this, BIM can be used to ensure compliance of the specification and standards. Building codes regulation can be integrated into design BIM model, which makes it easier to ensure that the design and construction of the building meet the necessary standards. This helps to improve the quality of the building and reduces the risk of non-compliance issues arising later on. Overall, BIM is a valuable tool, I must say, for quality control in concrete construction. It helps in identify and rectify design construction issues. By using BIM, construction professionals can improve the quality of construction, reduce costs, and deliver project more efficiently. That is very important thing.
True, Panjan. I think that was very informative. By seeing these slides, it seems like you want to correlate beam technology with construction facing. I would also say
Right,
this building information technology revolutionizes the construction industry by providing a powerful tool for a
right,
real-time tracking and monitoring of the construction progress, right? With
right.
BIM, construction professionals can create and manage a comprehensive digital representation of building project, including its design, construction, and operation. Um,
Right.
that's it is, it's just changing every day and day now.
Correct, correct, correct. And one of the, I need to add here also, one of the significant advantage of BIM technology is its ability to facilitate the identification of potential issues at early stage that I have just discussed. That is one of the
Yeah,
most important thing, I believe. And by creating a virtual model that integrates various components such as the architecture, the structural one that we are building, plumbing one, the electrical one, all the things that allow stakeholders to visualize the entire project before the construction even begins. The virtual
that is true.
representation helps in detecting the clashes and conflicts between different elements, such as the pipe, it can be ducts with the walls. In our structural elements, it can be wall with the slab or with the beam, which might be unnoticed until the actual construction even begins starts. And during the construction phase, BIM enable real-time tracking and monitoring of progress. Construction teams can input and update the information of the model, reflecting the actual status of each task, including completed work, work in progress, and any delay that you can see on the snaps or modification. This allows project managers to have an up-to-date overview of the project progress at every given moment. And real-time tracking and monitoring capabilities of BIM technology provide numerous benefits. First and foremost, I must say, it allows early detection of any issues or discrepancies such as design error, coordinations, and construction deviation. And by identifying this problem in virtual model, team can address them promptly, reducing the likelihood of costly rework, schedule delays, and budget overruns. And is in the slides you can clearly see on the top of hand, you can see the we can properly have a schedule that we are providing our client, which is running on schedule and which is making a delay, because there will be some issues with the designs also. There can be issues with the budgeting also. This can be happen through one of our software that you are using, that is the Synchro 4D. You all know about it. And the bottom hand right on the left hand, you can see this is the proper scheduling and on which day, which level, which element is going to be casted. Every detailed single is available there. So the project manager and the construction manager, they have a clear idea what to build next, how to build, and what is the time frame of that. So similar to that example on the right hand also, we at Pinnacle generally do this through Navisworks. That is the most common thing. And another thing I would like to say, Synchro 4D is the most powerful tool in this aspect as well. Now, by having the real-time tracking and monitoring, accuracy and efficiency improved by 33%, and rework and means issues that will be identified, that will be eliminated by 33%. Now, as you can see, all the things are correlated with the visualization. Without visualization, we cannot even think of the errors. We cannot even think of the construction issues. Now, here I would like to ask Babika. Babika is also here with us. What is BIM-enabled visualization and how it transforming the construction industry? Can you please elaborate to our audience?
Right. Thanks, Dipanjan. So yeah, let's start with what the topic means. So BIM-enabled visualization refers to the creation of a digital model that can help us visualize, simulate, and analyze various aspects of a building or a structure. It helps us with a virtual representation of the final product. Stakeholders can, identify and resolve design issues way before the construction starts. It cut down a lot of cost on site and also rework. So it actually allows us to save material cost, labor, and we can also easily mitigate the resources.
Okay.
Yeah. So yeah, okay, moving on to the significances. So I would like to ask you all, what do you think are some benefits of how we can save a lot of cost on site by visualization, and how we can integrate it into the BIM? If you all can say, anything.
Okay. BIM actually provides a realistic and accurate representation of how the final structure will be at
Right,
different
that's
loading
one.
and the construction stages actually.
Yeah, that's one.
Right.
So anything else?
Yeah, I think it also helps to optimize construction schedules, right? Like you
Right.
can get activity sequences. It optimizes the allocation of tools and equipments, and hence, it can help you to reduce cost, maybe.
Yeah, that's also another one. So these both are the biggest part of how BIM-enabled visualization is helping us in the industry. And apart from that, we also have early detection and resolution of design conflicts. So we have a 3D model,
Mm.
and it's way easier to, navigate through it and identify design conflicts and issues instead of managing all the 2D files. It also enhances
Right.
efficiency and mitigates risk of errors and misunderstanding. So on site, there are multiple files over there, and instead of shuffling through all the documents, it's easier to go through a 3D model on site as well. We have certain technologies
Mm.
that I'm going to discuss on later slides, but for now, it's just this one. And as Bhaumik said, it helps in optimization of construction schedules, right? So we can also, for example, we do 4D also, right? So instead of waiting on activity list, we can identify which element is going to be poured first, which element is going to be poured on later stages, and we can easily construct a 4D sequencing video, as Deepanjan said in his slides, using Synchro 4D or Navisworks. So there's also that. And it also helps when we know which pour is going to be poured first, and then after which element are going to be poured, we also can easily manage our tools, our tower cranes, resources.
Mm.
So it enables seamless integration of various building systems. So yeah, that's also another one. So we have various trades, and we can, in a 3D model, we can easily link all the models for mechanical, plumbing, electrical,
Mm.
architectural, structural, landscape even. So yeah, it's easier to,
Yes.
create a combined linked model.
Yeah, because I get this question asked a lot of times from my clients, how can we combine this in our construction workflow? So that's something that, that could help.
Yeah, we can easily combine them. Let's move on to the next slide. Yeah, right. So these are the three immersive technologies that we have nowadays. So on site, we can, use any of these, and it's really easier for site workers to for example, we are done with the designing, we are done with the construction documents, and the construction is actually ongoing. So we have these technologies, immersive technologies, through which we can identify. Let's move on with this first and then I'll explain better. So first one is augmented reality. So in augmented reality, we have a tab or an iPad, something like that, and with softwares like Unity and Autodesk Construction Cloud, we can easily scan a QR code, and on site we can see which with physical reality we have our model overlapped in on screen. So it's like just a background is physical reality. Our site is on the screen, and upon that we have overlapping BIM models. So that's what I was talking about. As our construction workers can see our virtual BIM model overlapping with the physical world.
True,
So
true.
yeah, apart from that, we also have virtual reality. So instead of augmented reality, we are totally cut off from the physical world. We have a headset and we are totally immersed into a virtual world. So you guys might have seen how we navigate through Navisworks. So that walk through or fly through, it's completely like that. But instead of that being on screen, it's totally, surrounding us as a virtual environment. Yeah, and in augmented reality, I can also think of one more example. So you might have heard about that feature on IKEA in which we can import, yeah, our furniture. We can take a snapshot
Right.
of our rooms and import our furniture and see how it will look like at different places. So augmented
Right.
reality is like that. So we also have mixed reality, and this is a newer concept for our industry. In this, we have, you can say it's augmented reality 2.0. We have like mixed reality glasses, and in on that the physical world is on the background. We are overlapping our BIM model or any model on that virtual
Right.
world on that, and instead of just observing it how it will look like, how identifying design issues, we can make changes also. We can play around with the elements. So
Yeah,
these are
it,
the three, yeah,
it
immersive technology.
definitely reminds me of Matrix movie. I think it's becoming
Yeah.
realistic.
Ah,
Yeah.
right.
Not so soon, but yeah, soon enough.
Yes, true.
Yeah. So let's move on to the next slide. Yeah, here I've added some of the data center models that I've created. Snaps are there, and how the site images came out to be. So on the upside, you can see we have BIM models, and below all are the real images of site, how it came out to be. So
Right.
you can see they have pretty much, everything, every concept, every detail, from notches, from openings to even the logo on the shutter. So yeah, I can say it's pretty, realistic. So overall, BIM enabled visualization helps us identifies issue like that. It,
We can
yeah,
clearly
and
see the reveals also.
yeah,
It's
Yes.
reveals
pretty
are also
accurate.
there. Thanks. So
Great to see
right,
this.
yeah, nowadays we are moving away from conventional concepts and moving towards more newer concepts like information modeling and information management even, and smarter construction approach. So yeah, we have Bhamik over here and I like to ask him about smarter construction.
Thank you, Bhavika. That was very informative. Now let's talk about how BIM is proving to be an important tool for smart concrete construction and how BIM has allowed us to determine smarter and faster ways of construction. Just like BIM-enabled facility management, BIM can also be a powerful tool for smart concrete buildings. Some of the ways are project lifecycle management, integration of sensors, and digital twin. In lifecycle management, we can involve BIM from the design stage to the demolition stage. By using BIM to manage the lifecycle, engineers can ensure the building is designed for durability and sustainability, and the maintenance and repairs are carried out in most efficient and cost-effective way. The first part of life cycle is design. BIM can be used to create a detailed 3D model of the concrete structure during the design phase. And this model can be used to simulate different scenarios, identify potential issues, optimize the design for performance, efficiency, and sustainability. Next stage would be construction. In construction stage, we are using BIM to manage the construction process of the concrete structure. Model can be used to plan and schedule the construction activities, monitor progress, and ensure that the project is completed on time and within budget. During maintenance stage, BIM can be used to manage the maintenance of the concrete structure throughout its lifespan. The model can be used to track the condition of the structure, schedule routine maintenance, identify potential issues before they become a major problem. Uh, I would also like to add repairs and renovation. This was not there few years back when no one was talking about repairs and involving BIM in repairs and renovations. But now BIM can be used to manage repairs and renovations of the concrete structure or any structure over here. The model can be used to plan and schedule repairs, track costs, and ensure that repairs are carried out in a safe and efficient manner. Demolition, another advantage of BIM. BIM can be used to manage the demolition of the concrete structure at the end of its lifespan. The model can be used to plan and schedule the demolition activities, track cost, ensure that the demolition is carried out in a safe and environmentally responsible manner. Uh, we can use BIM in concrete structure for integration of the sensors. Like by integrating embedded sensors in the concrete structure, we can monitor the structural integrity and performance of the building. This can help to identify potential problems before they become critical. A few of the sensors that are available in market today are shown in the slides. Many of these sensors have different functions and are available today as such as fiber optic sensors, piezoelectric sensors, self-sensing sensors, wireless sensors, and many others. I would like to say, can you all think of how BIM can be advantageous in sensor integration? Anyone?
Yeah. One of the major benefit that I know, my currently working, or you can say, I'm just thinking of that, like the sensor placement. The BIM can be used to determine the optimal, placement of the concrete efficiency sensor in the structure also. And by analyzing the 3D model, designer can identify areas that most prone to cracking, the settling or any structural issues, and placement sensor in those areas to monitor the potential problems when they become before they become major. So that is how the sensor is going to be, added values to our industry also.
Well said, Deepanjan. That is indeed a great example. That I could say, that's one of the biggest advantage that we have today, and we should all start using that. Along with along with that benefit, I would also like to add few others. BIM can actually help us to select the most appropriate type of concrete efficiency sensors, and for any particular application. There are many different sensors available as shown in the slide. Each has their own strength and weakness, but by analyzing the 3D model and considering the factors such as loads, environmental conditions, and lifespan of structures, designers can select the best sensors for the job. Next advantage that I think of is data analysis. We all want to analyze data today, how building is performing, how structure
Right.
is reacting, how loads are acting on a structure. BIM can use to collect all the data, and it can help us to derive the efficiency of the concrete. By integrating sensor data into the BIM model, designers can actually monitor the structural health of the building in real time and identify potential issues before they become major problems. This does help to reduce maintenance costs, increase safety, and definitely it will help to extend the lifespan of the structure. Another advantage, automation, right? Like, I mean, you are looking at Chat GPT now, right? So it's way above what I thought anything would be. It's like 2 years before. BIM can be used to automate the collection and analysis of the sensor data by setting up automated workflows and notifications. Designers can be alerted when sensor data indicates a potential issue, allowing them to take a proactive step to address the problem before it becomes more serious.
Right.
I one more thing that I will add to this is just like we have digital twin for facility management, I would say BIM-based digital twin can be used to monitor and analyze the performance of structure in real time. Sensors can be integrated into the digital twin to collect data on the structural health of the building, such as temperature, humidity, and strain. This data can then be analyzed to identify potential issues before they become major problems. It can also be used to simulate and optimize the structure, like 3D structure created in BIM can be used to simulate the realistic structure that has been already constructed or that is going to be constructed. A beam-based digital twin can be used to simulate and optimize the performance of the concrete structure. By analyzing the 3D model, designers can identify potential improvements in the structure energy efficiency, integrity, and sustainability. And they can stimulate the performance of these improvements to determine the most effective solution. Third benefit of creating a digital twin model would be disaster response. A beam-based digital twin can be used and can support disaster response efforts by simulating the performance of the digital twin under different disaster scenarios. Emergency responders can identify potential risk and plan their response accordingly. Now, I would like Preetham to continue from here. Preetham, can you please give some insights on how BIM supports each stage of construction?
Yeah, definitely. Thank you, Bhumik. Yeah. So BIM, as per the discussion we had, we have already understood that BIM supports every phase of the life cycle. So I would be telling about the three different phases of the construction where BIM can act as a support. So first one is like a pre-construction phase. In the pre-construction phase, BIM helps us to visualize and the simulation of the project design. It helps in site data analysis and optimization and material taking and management also. In the construction phase itself, BIM helps us to construct the scheduling and tracking the scheduling and the progress monitoring also. Then it helps in quality control and issue identification. In the post-construction phase, when the building has been already constructed, then also BIM acts as facility management. BIM helps in facility management and maintenance scheduling also. BIM helps in building performance monitoring and its control, and BIM automated the building management system as well. So here, by this process, BIM helps us in all the stages of the building. When the building is not been constructed, even that is in the pre-construction phase. When the building is being constructed, that is in the construction phase, and when the building has been constructed and that is fully working, people are going there, the building is being constructed, building is being used by the users, then also BIM can act as a very useful tool. So BIM helps us in every phase of the life cycle of any particular building. So that is how we can leverage the use of the BIM in each and every stage of the construction. Here I will be discussing about the benefits of adaptation of automation in BIM. Let's first understand why we need automation in BIM. As per the report of Autodesk, the BIM itself provides 88% better design insight. It provides 82% positive ROI. Then BIM eliminates rework by 84%. It reduces cost by 69%. BIM itself acts as a solution of all of this. However, BIM needs the power of automation to push the envelope to help the project stakeholders to save more money and time. The early stage of construction, which we generally say the pre-construction, is the key area to get these things done. BIM automation refers to automating the repetitive process, leveraging the quality and the enhancing the overall productivity. As project complexities continues to increase, BIM automation is something crucial to improve at any stage of the project. And automation in the context of BIM involves the use of various software tools, various algorithms, and design systems to streamline and optimize the various tasks and process in the construction phases. This integration enables the automation of repeating and time-consuming and error-prone activities actually. So it leads to improved efficiency and accuracy and productivity in the construction industry. Here are some key aspects and benefits of BIM-enabled automation, which I will be discussing. Firstly, BIM helps us to automate the design concepts. So BIM enables the design automation of design tasks by utilizing the parametric modeling technique. Then parametric model allows designers to define the relationships and the constraints between different elements in the model. By changing one parameter, the entire model can be automatically adjusted by saving time and effort. Also at the project design finalization stage, as many RFIs, design changes, ASIs, and addendums come into place, the parametric model is able to change itself based on those additional changes. It not only reflects the actual geometry of an object, it also gives us the quantification of the object, quantification of the entire building at any time.
Right.
Yes.
So BIM had some effects on identifying the clash detection and the and it helps us to coordinate among different trades also. BIM enabled automation includes the clash detection algorithms that automatically identifies and the flag the clashes or the conflicts between the different building elements such as structural components, electrical systems, plumbing system, etc. It helps to detect and resolve the conflicts early in the design phase. It minimizes the rework and the potential issues during the construction. Thus, by using the automation, we can make any building clash-free to to get it constructed at the site seamlessly.
Yeah, right. And Preetham, we also have certain in-house, add-ins in PiVDC to help with that. I used that software. I used that add-in in Naviswork in a data center for clash detection, and data center is heavily, packed with services. So it
Right.
was a really big project for us to work with that. So
Yes,
yeah,
data centers, hospitals, and these type of buildings are actually accommodated by various types of trades. Actually,
yeah,
there are difficulties in mechanical trades. There are complications in electrical, mechanical, and all other
Right.
trades. Actually, we have to
yeah.
have the use of we have to leverage the use of BIM to successfully construct those type of buildings. Actually.
Correct.
Right.
So yeah, we had electrical documents in that doghouse locations were something else, and in structural documents, the openings were somewhere else for those
Mm.
doghouses. So we had a lot of trouble with constructability issues as well. But our
Yes.
add-ins really helped us. You should use them more often.
And
Yes.
yeah, we are using it, and in the upcoming slides, we're going to showcase us to our client also or the audience who are we're going to see this.
All right.
This is going to be a path breaking for BIM automation. So we'll be moving forward on that part later on.
Yeah, and also add how many projects we have used that on, like I think that will
Yes.
be good.
Yep.
Okay. Moving to the next, like thirdly, BIM have some effect on the quantity takeoff and the cost estimation also. Rather than coordination and all those things that we are discussing, BIM has some effect on before starting the building, we can have the quantity of the actual building also altogether. BIM automation tools can extract the quantities and perform the cost estimation by analyzing the BIM model. This eliminates the need for manual quantity takeoff. This reduces the human effort and it provides more accurate and the consistent cost estimate as well. And BIM has some effect on the construction scheduling and sequencing also. BIM enabled automation allows for the for automatic generation and the construction schedules and the sequencing plan based BIM model as well. It helps to optimize the construction sequencing, then identify the potential bottlenecks, and improve project planning and the coordination as well. It gives an idea about the project timeline way before the project actually starts at site. Also, BIM has some other uses as well. It has in 4D construction sequencing, BIM can be combined with 4D with construction scheduling softwares to create 4D construction sequencing models. BIM models can provide a visualized representation of the construction process and help to identify the potential issues and optimize the construction sequence. BIM can help in the 5D cost sequencing as well. BIM technology can also be used for 5D cost estimation, which combines the 3D BIM model with the cost data and the time schedule. This allows the stakeholders to create the accurate and reliable cost estimate throughout the entire project lifecycle. And BIM helps in the 60 facility management as well. BIM can be used for the 60 facility management, which includes the use of BIM model for building maintenance and the operations. This allows the stakeholders to create accurate and up-to-date facility management plans, which can lead to better building performance and reduce the material costs.
Right.
Yes, and Pritham, let me add one more point over here. I was just looking at LinkedIn yesterday and I saw that there is
Mhm.
10D now, right? Not up to 6, but 10. So, there is a lot
Mm.
to add. Even there is safety now. And this construction industry needs to change a bit, and I think BIM is actually providing the right direction because it is helping to save cost and it is making things
Mhm.
faster, right? But I would
Yes.
also like to add a sustainability, BIM and sustainability. Today, BIM technology can be used to optimize building performance and sustainability by analyzing factors. I'm sure energy efficiency that we try to calculate in our BIM models, right, for a lot of our electrical projects. And, we can also
Mm.
calculate today water usage and even carbon footprint, right? They can help stakeholders to make informed decisions about building materials, systems, and design choices that can reduce environmental impact. I can go on all day, but, sorry, I cut you out, but I just wanted to add about sustainability over here.
Yeah.
And to add to Bhaumik's point, he's right about the 10D we had. I also saw the post on LinkedIn, but I'd like to add that all that is covered in information management only. So yeah,
Mm.
we all
Yes.
so Preetham, you talked about how these BIM uses are integrated into a project life cycle, but can you please go into more detail about how they are integrated into concrete construction?
Okay. Okay. Thank you for the question, Bhavika. Yeah. Here I can give you some example how we can leverage the BIM technology into construction actually. So here
Okay.
I can discuss about how we can use BIM the most. Here are some aspects. Okay, first, BIM helps in strong collaboration among the stakeholders. BIM brings a collaborative process that among all the involved heads by collaborating them all and checking all the clash detection, which ensures a smooth process that can make the actual construction hazard free. Then secondly, BIM helps in optimizing the time of construction. Since we can actually model the virtual replica of the actual building, then check the different aspects of the construction, it actually reduces the time that is required for the actual construction at site. Thirdly,
Okay.
it helps us in optimizing the construction cost as well. In BIM, by checking all the aspects of the construction, construction of the actual building, BIM can remove all the possible hazards and the extra cost even. It ensures the chances of costly on-site repairs of the building. Fourthly, it helps in improving the scheduling and the sequencing of the building as well. By using the different aspect of BIM, we can map the scheduling of the building and even sequence the different phases of any construction way before the building actually start
Mm.
constructing. Then it helps in reducing the material waste even. BIM can ensure the actual quality. BIM can help us to measure the actual quantity of the material that is required for the whole construction. It helps to fix the accurate budget of any particular project. BIM can be used as an useful tool at all the aspect of any construction, since it helps in generating the actual geometry. It provides the quantity takeoff, it helps in the scheduling and mostly in the after construction data management as well. Thus, by various this type of things, we can actually leverage the BIM technology into construction by using it at every phase of the construction, by using it in every way possible. We can use the BIM technology in construction.
Now,
So
the slide
Okay.
that we have all been waiting for.
yes,
Yeah.
Now, PiVDC. Okay, since so we are talking about or discussing about the use of automations and leveraging BIM into construction, I want to ask all the audience: are you tired of using, the same repetitive or traditional way of doing your work? As Bhavika has said, she is using, we are using, and we want all of you. You can use the automation industry, means you can break through the industry through automations. So let's get started with PiVDC. However, in Pinnacle, we have one more in option to go beyond the automation. That is, you can say PiVDC, in which we have Pi Mechanical, Pi SAS, means Pi Architecture, Civil Structure, Pi Docs, means various types of add-ins are there. There are 1500 plus add-ins are we are currently using day by day. And I would like to request Pritam, we some of them of my clients, I have already talked with them. I have provided them the material, the brochure, so they are currently using it. They are pretty much happy to using that in the industry. So can you elaborate a bit about what is PiVDC and how this is helping the clients? That's I wanted to know from you.
yes, Dipanjan, you rightly said. In Pinnacle, we have one more in-house option to go beyond automation. Yeah,
Right.
say hello to PiVDC, the ultimate suite of automation tools and technologies designed to bring the revolution in the BIM industry. We provide automation for Revit and Naviswork Manage from the version 2019 to 2024. Our products are PiDoc, PiMechanical, and PiNaviswork. It is proven that the PiVDC by the use of PiVDC, you can save over 10,000 hours and you can increase your productivity by 15 to 25% on your BIM projects. Our add-ins has been used in more than 3,500 projects in over 40 countries, which makes us a trusted solution in the VDC world. PiVDC automates every stage of your project flow from modeling to construction, modeling to coordination of to soft drawing and prefabrication and quality checking even. Don't miss out the revolution in the BIM automation. Check more on our website and our online platforms or contact us to learn more on the specific packages that can transform your workflow.
And you can also visit the website, that is pivdc.com. So I'd like to request the audience, please go through that website. We'll be getting all the details. And if you would like to implement this to a workflow, please get back to us. We'll be going to happy to assist you, and we're going to happy to inform you about the detailed add-ins that we are using. Thank you very much.
Thank you, everyone. Thank you so much. Thank you for
Thank you,
attending our
everyone.
webinar.
Yeah.
Bye. Bye.
Bye.